Hello students, welcome to Maths Online Academy by Sandhya, myself Sandhya. Today topic is from chapter 1, real numbers, rational numbers. Today we discuss what is rational numbers. What is rational numbers means a number that can be expressed in the form of P by Q. So the number should be in the form of P by Q, where Q is not equal to 0 is called rational numbers. So numbers, for example, we know natural 0, 1, 2, 3, 4. These are the numbers na? So 0, 1, 2, 3, 4. These are normal numbers. So for 0, you can write 0 by 1. For 1 also 1 by 1, 2 by 1, 3 by 1. If you don't have denominator, but you can write the by 1. So in the form of P by Q is called, and one condition is there, Q must be not equal to 0, is called rational numbers. Examples are 1 by 2, 3 by 4, minus 5, 0.25 and 0.333. Here these all are rational numbers, but this is different, like this is different, this is also different, this one also different, this one also different, this one also. All are not same. Why means in rational numbers based on decimal points. These are decimal points, na? These are based on decimal points. Those are two types: rational numbers and their decimal expansions. Let's discuss their behavior. Terminating decimal numbers and non-terminating recurring decimal numbers. We discussed rational numbers means the form of P by Q. So that is expressed P by Q form and Q not equal to 0. In this terminating decimal numbers, for terminating decimal numbers, examples are 0.375 and next 1.04. Means after decimal point the number is finite. After decimal point the number is finite, means not repeating, it finite, it ends with the some number. These are called terminating decimal numbers. And the non-terminating decimal numbers, P by Q, Q equal to not equal to 0. Example is 1 by 3, 0.3333, it will come answer. And for by 2 by 7, it will come 0.28571 and so on. It will continue. It doesn't end, it will continue. These are non-terminating recurring decimal numbers. So these are terminating decimal numbers, ends with the some finite number. Those are called terminating decimal numbers. It doesn't end with the number, na? Those are called non-terminating recurring decimal numbers. Based on these two also we have one more numbers. We discuss after that one. Okay. Now we discuss next theorem. Theorem number 1.3 based on the rational numbers, and one more topic is here, co-primes. Let's discuss that one. Co-primes. What are co-primes? Prime means prime numbers, but this is different. Co-primes. In next theorem we discuss this topic only, co-primes, and based on rational numbers, co-primes and decimal expansions. Co-primes. Co-prime means if there are two numbers, for example A comma B are two numbers. if the HCF of A comma B is 1, those are all called co-primes. HCF is 1, those two numbers are called co-primes. In that numbers, no need to be a prime numbers. Only HCF is 1, those two numbers are called co-primes. In the, for example, 4, 5. These are two numbers now. In this, 4 is not a prime number. But in this, these two are co-primes. In these two numbers, no need to be a prime number. That number is HCF is 1. These two numbers are called co-primes. Okay. Next theorem. Theorem number 1.3. And the next theorem 1.3. First see what is the statement. Let x be a rational number whose decimal form terminates, then x can be expressed in the form of p by q, where p comma q are co-primes and the prime factorization of q is of the form 2 power n 5 power m, where n comma m are non-negative integers. So in this, let's take one rational number x and we have to show those decimal form terminates in the form of p by q, and p and q are co-primes and q factorization is 2 power n 5 power m. For this, we take one example. So, for example, 1.25. Is it rational number? Yes, this is the rational numbers. So, let this is the x. X be a rational number whose decimal form terminates. This is the decimal form of the x. Then x can be expressed in the form of p by q. We can write this is in the form of p by q. So, write 1.25. In rational numbers, if you remove this point, how many numbers are there after the point? 2. So, directly you use 2 zeros. So, 125 by 100. So, you divide 5 table. 5 2s and 5 5s. 5 2s and remaining 0. Yes. 5 5s and 5 4s. The final answer is 5 by 4. Is it in the form of p by q? Yes, it is in the form of p by q. Here q not equal to 0. Up to this we finish in the form of p by q, and we have to show where p comma q are co-primes. Already before we discussed what are co-primes. The numbers which has HCF is 1. HCF is 1 means those two are co-primes. So here p comma q are 5 comma 4. For this, do factorization. 4 1s are 4 and again 5 1s are 5, 5 1s are 5. In this common 4 comma 1. In 5, 5 into 1. For 4 factorization, 4 into 1. For 5 factorization, 5 into 1. What is the common in these two? 1 is the common. So 1 is the HCF of 4, 5. So these two are co-primes. This one also finished. And the prime factorization of Q is in the form of 2 power n, 5 power n. So, what is the Q here? Q value is Q equal to 4. For 4, you can write 2 into 2. Yes? 2 into 2 means 2 square. But here we have to show 2 power n, 5 power m. Here you can write 5 power 0. For any number, power 0 means for any number 5 power 0 is 1. 2 power 0 is 1. This is the normal math. 5 power 0 means value is 1. 2 power 0 means value 1. So, this is look like a 2 power n into 5 power n. Say. So, and here n comma m are non-negative integers. What are integers? Integers z equal to what? -3, -2, -1, 0, 1, 2, 3. These are integers. Here clearly mentioned n comma m are non-negative integer. Non-negative integer means these na 0 to 1, 2, 3, 4, 5. So here also say n value is 2, m value is 0. So n comma n also non-negative integers. These are non-negative integers. From starting, let's see. This is the x. Let x be a rational number. We are taking this is the x 1.25 and we are converting into p by q form. P by q form. So p by q form means it became 5 by 4. And here q also not equal to 0. P value is 5, q value is 4. And these two are co-primes. 5, 4 are co-primes. 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 And q value is 4. For 4, you can write 2 into 2. 2 into 2 means 2 square into 5 power 0 means 1. This look like a 2 power n, 5 power m. N comma n are non-negative integers. Finally, hence proved. For the same, you can express one more example also. We take here. This is for 1.25 na 5. For example, x value here you take 3.15. So 3.15 by you remove the point 100, 5 6 30 and 5 3 is 5 2 is 0. So final answer is 63 by 20. 63 by 20 means 63 ones are 60 and 1 is the factor. Here 20 and 1. In both 1 is the common factor. So these two are co-primes. That implies 63, 20 are co-primes. Co-primes. And next, prime factorization of q. Here q value is 20. 20 you can write what? 2 into 2 into 5. Yes. See. 2 tens and 2 fives. So 2 power 2 into 5, 5 power 1. This is similar to 2 power n into 5 power m. Here these are positive, positive integers. So n comma m are non-negative integers. Hence proved. So here everyone is proved. This is in the form of p by q and q equal to not equal to 0. These two are co-primes and q is in the form of 2 power n, 5 power. And n comma m are non-negative integers. Okay. So in the next class we discuss, this is the 1.3 theorem. In next class we discuss 1.4 theorem. If you like this video, please subscribe and share the video. Thank you.